All right, now I want to compare that next to correlational research, which is also part of this chapter. And this is where the visualization data is really going to be different. So here I'm comparing groups, but in correlational data, what I have is an individual and multiple data points about that individual. Another individual, multiple data points about that individual. All right, so for example, let's say I'm looking at value-added scores for teachers in multiple years. Okay, and I don't know what an actual value-added score might look like, but I'm guessing that the numbers are going to be somewhere between 0 and 2 for every teacher. Right? 1 might be considered 1 year's growth, 2 would be 2 years growth, and 0 means you had no effect on your students. That's pretty bad. So we've got teacher 1 here. Her first year of teaching, she gets a 1.4, which is pretty good. And then what we're doing is saying, well, that one teacher, how is she, not a group, but how is she going to do the next year? Well, the next year she gets 0.3, and that's not so good. And it also tells me that, wow, that 1.4 did not predict the 0.3. Now, I could also collect data on that same teacher every year from multiple years. And if I did that, I could have a spreadsheet with her year 1, year 2, year 3, year 4. Or as in this study did, took a number of years and took the average for those years for that one teacher. So then the comparison I'm making is the 1.4 a good predictor of this number over here, 1.2? Well, it looks like it is the way I set it up. Now, I have a second teacher, and I'm looking at the same kind of question for this person. So 0.3 in the first year, not looking so good, maybe not going to keep their job. Second year, 1.2 rose to the top, above average. So again, the way I set this up, the first year did not predict the second year. But now this teacher keeps going, year 3, year 4, year 5, year 6, and year 2, it turns out, was a little bit of an anomaly. Maybe year 1 scared him and he did his best year 2, maybe bribed the kids in year 2, I don't know. But years 2 through 6, 0.6. So got better, and the first year did not totally predict that, but it seems like it's in the ballpark. But my point here is that we're looking at this teacher and how she does year 1 compared to year 2, or year 1 compared to years 2 through 6, and then separately this teacher, same kind of comparisons. We're not doing group comparisons with correlational data. Now, again, look at the group average data, and what I've got is 40 students, 20 in one group and 20 in another group. But if I look at what correlational data might look like, in this case, let's say I've got 20 teachers and I'm doing this value-added kind of analysis. And I don't have groups, and I'm looking at each teacher and how does year 1 predict year 2, or how does year 1 predict their career. And I purposely made up this data to make it look the way I did. And so notice that this data is consistent with the thesis in the Kane and Steger article that you're reading. So it says that this teacher, teacher 10 for example, had a really high score in year 1, but a really low score in year 2. So it's saying that year 1 did not predict year 2 well, but look, it really predicted their career well. That's the argument being made by Kane and Steger. Same with this teacher in green. First year bad, second year really a lot better, but career more like the first year than not. So, but again, the point is that we're looking at person by person by person and multiple data points for the same person, as opposed to looking at a group and how a group compares to a group. Now, you'll always see it portrayed as scatter plots. So this would be the scatter plot for year 1 compared to year 2, and you see there's no particular pattern. I'm exaggerating all this. And then here you see year 1 compared to the 2 to 6 year average, and you can see clearly some kind of relationship that the higher you go up here, seems like the higher you go up here. And it's not a perfect fit, but it's a pretty high correlation. Again, this picture is consistent with the kind of argument that is being made in the Kane and Steger chapter. Okay. But the point is, each data point here represents a person, okay, not a group. And there are two values for each person here. One value, which is the, you might call it the X value, is, I think, the PVAS year 1 number. And the other data point is the Y value, and I think in this case it's the number that's associated with that person here. So each dot here represents one person, but two different data points about that person. And we're seeing, is there a correlation between those two data points, right? With two data values. Okay, so we're going person by person, and you can clearly see from the scatter plots, and also if you analyze the actual numbers here, that there's no good relationship between these two columns for each person, but there is a pretty good relationship between this data point and this data point for each person. Right? Now, to underscore that we're not looking at groups, I did calculate the average for these three groups. And you can see that even though this second group is not being predicted by the second data point is not predicted by the first data point, when you look at them as a group whole, yeah, they're kind of similar. Well, that can be because, you know, here you had a low score and here you had a high score, and the opposite here, and they kind of average out when you go down here, which hides the fact that the first data point did not predict the second data point. So we're not looking at averages. However, the correlational statistic is a way of looking at each of these data point relationships one by one, and what can we say about the trend as a whole. So you're going to get numbers that are from -1 to 1, and if they're going in the positive direction, instead of like this, they're going to be positive. And if they're getting close to a line, and you can fit the points on a line perhaps, or close to a line, then they're getting closer to 1. And if there's no general pattern here at all, the correlation is probably close to 0.